Let's take a look at creating a DTM or TIN model from GeoPack Survey. First I'll go up to my Survey menu bar and select DTM, Build DTM from Survey Data. The first thing I would need to do is to fill out a file name for my TIN to be created, or I can go out to my Files button and browse for a TIN I wish to create. In this case, this is called JCJ Raw 1, which is going to be a DTM of that particular data set with that name. Since my file already exists, I'll receive a prompt as to whether I would like to overwrite the file or not. I'll select OK, and then I'll take a look at my dissolve options. The first option is None, which will allow GeoPack Survey to build every triangle that is possible with this TIN model. If I click, I'll see that I have two other options, one of which is Sliver. Sliver will use a built-in algorithm to go ahead and thin the very angular thin triangles that you'll receive on the outside of projects typically, and it will do this automatically. The last option, which we find most used, is the side option, and what this does is allow us to define essentially a spacing or rule of thumb between our shots, and that rule of thumb is approximately 1.5 times the distance between the shots on a linear basis. For my settings here, I'll keep the side length at 75, and then moving further down the dialog box, we have the option to create a DAT file, which is an ASCII file of the DTM model. I can write comments such as processing messages and any errors that occur in that file. And similarly, as we have with the name of the DTM itself, we can give the data file a name, and I'll call this the same as my TIN model, with the exception the extension will be DAT for DAT, and I can also browse to select that file. The DAT file itself has a couple of file open options, one of which is to create file, which creates a brand new DAT file, or you can append to an existing file, and this can be used to go ahead and add a second data set to an existing DAT file if need be. I'll choose Create File. For my file mode, I'll let that be an ASCII file. I also have the choice of binary. Binary does run a little bit quicker, but I'll choose ASCII in this case. Moving further down the dialog box, I have what are called stroking parameters. And the general purpose of these is to let me densify my triangulation network for the TIN model. I will go ahead and check on stroke curves, which will give me an arc stroke tolerance. I'm going to change this value. What this value works out to be is the middle ordinate between a chord distance or a chord length between 2 points and what a quote curved break line would be like if it were to go between 2 points. So it's essentially the middle ordinate distance, and we want to set a maximum for that, in this case of, let's say, 1/10 of a foot. I'll also check on stroke linear, and what this will allow me to is to place additional points in between points that are on my break lines. So let me change this to be a value of 25, and what this will do is insert additional points in between consecutive points on my break line or survey chain that is a distance greater than 25. The last section of the stroking parameters is determine DTM inclusion from, and here we have three choices. We have determine DTM inclusion from feature table, the point chain attribute field, and all points and chains included. All points and chains included does exactly what it says. It includes all points and chains in a particular data set or option that the user chooses as far as points and chains to load into the TIN model, and they will all be included in the triangulation. A second option is the point chain attribute field, and what this will do is have GeoPack Survey actually go out and look at the point and chain attribute field for particular points and survey chains and look at each and every one of those points and survey chains and see whether that is an attribute that should or should not be included in the DTM. Lastly, we have the option to determine DTM inclusion from feature table, and what this will do is honor the settings as defined in the feature table. If a survey chain, for example, is defined in the feature table as a break line, then that will be honored when loading into the TIN model. If a survey point is labeled in the SMD file for a particular feature code as a feature or do not include, then that will be honored for that point and it will not be loaded into the DTM or TIN model. The last section here on the dialog box is the supplemental DAT file. If I check that on, we'll see the Files button become available. And what this would allow you to do is to go out and browse to select a DAT file. And the format of that DAT file is exactly the same as we would be able to create with this dialog box. The most typical use of this is a DAT file will be received from photogrammetry that creates a DTM model, and then the surveyors will go out and pick up data sets in areas where the terrain model from photogrammetry is incomplete or obscured by trees or other obstructions such as that. And one thing to be careful of with the supplemental DAT file is all of the data in this DAT file will be used regardless of whether that data overlaps ground survey data or not. So what some surveyors will do is go ahead and use the DTM merge process, which allows you to cookie cutter out sections of the photogrammetry data and then replace that with the survey data. So that's just something to be aware of when using the supplemental DAT file option. In my case, I do not have a supplemental DAT file. So now what I've done, I've set up everything to go ahead and build my DTM model, and the default behavior will be to go ahead and make that model from my active data set. I'm going to go ahead and click the Set Search button and choose a particular data set from which to make my terrain model. And this data set is going to be the JCJ RAW1 data set. This Set Search button is found throughout GeoPack Survey, and it provides you many options for picking by data set, and also has a button which will allow you to get even more refined and pick more detail. For a better description of this functionality that we won't go into here, take a look at the pointedit.avi file, and that will give a very detailed instruction on how to use Set Search and the more detailed dialog box. In my case here, it's sufficient for me just to pick the data set that I wish to use. I will click OK, and then go back to my DTM dialog box and click Process. I'll receive a warning that this file already exists, and I'll say yes because I do wish to replace this file. If you look down at the status bar in MicroStation, you will see where the processing of chain data is going into the DTM, and then there will be a message displayed when the DTM creation is complete. We're now processing point data into the DTM, and our DTM creation is complete. Those messages tend to go by very quickly, so if you wish to take a look at them, just click on the Message Center for MicroStation, and then you're able to see the last few messages created by the DTM engine. Writing 10 file and build triangles completed. I'll go ahead and close that, and now I'll take a quick look at the DTM model that was created from this command. To do this, I'll go ahead and close my DTM building dialog box, and I will go to DTM from the survey menu and select Load DTM Features. This brings up the Load DTM Features dialog box, which I won't go into much detail here other than to show you how to display the triangles for this. So let's choose to load a file type of 10, which I've just created, and then I will choose triangles. I'll click this light bulb to turn on triangles, and then double click here to define my triangle symbology. We'll use red because that should be very visible for our demonstration purposes. I have display only checked on, which is essentially a preview. It does not draw the triangles into my DGN file permanently. Let me click load. I'll go ahead and close this. I'll save my load settings to the project manager so they'll be available for next time. And now you can see the DTM model displayed in preview.